So this is an interesting multiple choice question on similar and congruent triangles. And here we want to know why the two triangles are congruent. Okay, so I'm going to ignore the multiple choice solutions until I can come up with my own conclusion, because what this involves is dissecting the triangle for what we see it has. Okay, so they're telling us that point G intersects the lines AC, and DF. And I see that from G to D and G to A, we have the same 11, which means that this whole length, given that GC is 6, would be 17. Okay, so I'm going to make that line I know is the same as the length of this one is 6 and 11. Okay, so those are two similar things. And then I can see the same thing over here, that from C to E and B to F, I have this 14.4. So those two sides are the same length. All right. And then if I go ahead and look at the middle, well, I see that, oh, look at this. I have a 6. And I have a 6, which means triangle FGC is an isosceles triangle. So we know that these two sides are the same. So by definition, I know that that angle and that angle are the same. Okay. Now, how can I know that these are congruent triangles when we're looking at A, B, and C? So A, B, C, if I want to draw it out by themselves on the side, I can see that A has this long length of 17. And then from B to C, it would be 15 centimeters. And then we know that angle C is that dot. Okay, so that's my triangle A, B, and C. Now, if we look the same for D, F, and E, we can conclude a similar thing. And by similar, I will mean congruent, because 11 and 16 is 17. We know if that is D, that is D, that is F, and that is E. And then so we know from E to F, once again, 10.6 plus 1.4, so that's this length here, just like before it was this length here, you get another 15. And then we had, because of that internal isosceles triangle, we know that this angle is also the same. So look, we got a side, a contained angle, and a side. So by SAS, these two triangles are exactly the same. If I were to go ahead and use, assuming these were 90 degrees, if it was rectangle, we can't assume it, but if I could do the Pythagorean theorem, I'd get the same thing there and there. So let's look at their solutions, because the three corresponding sides are the same. So that is an SSS situation, but we don't know the third side, so that is not ours. Because two pairs of corresponding angles are congruent. We actually don't know that this is 90 degrees. We only know one angle. So it is not AA. Okay. And no, because two sides and the contained angle, and this is really important, the idea that it's contained between the two sides are congruent to the two sides of the contained angle to the other side, meaning this side, this angle, and this side are the same as this side, this angle, this side, because that's what congruent means. They are equal, they are the same, right? That means same. And that is the situation. Two sides and their contained angle are congruent to the two sides and the contained angle on the other side, because we know these two angles are the same. Those two sides are the same. So isosceles triangle, that's how we know the angle piece, and we have the same sides. Notice, let's say it was 90 degrees, the hypotenuse, okay. And so that seems to work. And then what would be the last one, just for fun? Two angles in the contained side of one triangle are contained to two angles. So this would be angle side angle, which is not the case. So once again, we have congruency here because of side angle.